Okay, number 21, I realize some students are going to be looking at this problem and wondering how I got that blue area. So what I'm going to do is go to the whiteboard and we'll go through it. And hopefully by the end of it, you'll have a better idea what I did. Let's go to the whiteboard. And the first thing I'm going to do is write down the general term, AN. So AN is equal to 2J and J plus 1 over J plus 2. All right, what I'm going to do is break it into two terms using partial fractions. So I'm going to say A over J plus 1 plus B over J plus 2. And this is supposed to be equal to 2J, J plus 1 over J plus 2. Well, if you remember, we did partial fractions way back. What I'm going to recommend you do is multiply both sides by the LCD, and you get 2J equals A times J plus 2 plus B times J plus 1. I'm going to pick an easy J value, for example, J to be, I don't know, minus 1. What would that give you? Minus 2 equals A. So this tells me A is minus 2. Let's pick another easy value. For example, J is minus 2. And what would you have there? Minus 4 equals, let's see, it's going to be B times minus 1 or minus B. What does that mean? B is going to be equal to 4. So I can write this down, 2J, J plus 1 over J plus 2 is equal to, well, let's take a look at it. The B is 4, so I'm going to write down 4 over J plus 2 minus 2 over J plus 1. Now, I'm not going to say it's a telescoping series, but it sure does look like we'll benefit by writing the terms down now for the nth partial sum. So let's write this down. The nth partial sum is going to be the sum J equals 1 to N. And instead of writing down, AN, I'm going to write down the partial fraction form of it, which can be 4 over J plus 2 minus 2 over J plus 1. Now, before I proceed, what I'm going to do is I'm going to factor out a 2. So let me get my eraser out. And I'm going to factor a 2 out. I'll write that down for you. It's going to be, let's see, 2, and this will be 1. Right, the whole point of this is to write down a partial sum, see if I see a simple pattern to it. And you may not see a simple pattern. That's possible too. The hope things cancel off, but let's not get our hopes up. So I'm going to write this down as 2. And that's going to be, let's see, 1 plus 2 is 3, right? Minus 1 over 2. Plus 2/4 minus 1 over 3. Again, my recommendation is to write down a couple of them, or a few, as many as you like. This would be 2 over 5 minus 1 over 4. All right, keep going. 2 over 6 minus 1 over 5. I'm just going to keep going. It goes on forever. No, it doesn't. It's finite, right? So it's going to stop at some value n. Now, of course, I'm going to write down a few of them because I want to get a feel for what it looks like. Again, we're going to n, so what's the last one going to be? 2. N plus, again, we're just looking at the generalized term, plus 1, plus 2, minus 1 over n plus 1. Let's do the one before it. That would be 2 over n plus 1 minus 1 over big N. It's going backwards now. 2 over N minus 1 over N plus 1. All right, so this gets a little tough right now because what you're looking for is something that you're hoping working out pretty nicely. And so what I'm going to do is I'm going to circle what I see. And by that, what I mean is I'm seeing a pattern like this. And this is fine. I can associate these any way I want. All right, let me go towards the end. And I hope you realize there's going to be something like this here. And there's something like this here. By the way, there's also something here. I think you get the idea, and there's something over here too. And of course, things in the middle. So what I want to do is I want to kind of write down what I think I'm seeing. Let me go back. I think I'm seeing a 2. Let me go back over here. Well, that minus 1, that's sort of like a loner there, right? So minus 1/2. And then I'm seeing something in the end that's not paired up. I'll write that down. So it's plus 2 over n plus 2. And then I'm looking at these guys over here, and I got to be careful about it, right? So I'm going to start writing them down. 2/3 minus 1/3 is going to be 1/3 plus, again, I'm just doing one at a time. 2/4 minus 1/4 is 1/4. I think you see what I'm doing over here. Let's say 2/3 minus 1/3 is 1/3. 2/4 minus 1/4 is 1/4. 2/5 minus 1/5 is 1/5. I'm going to say yada, yada, yada. I want to go towards the end. And I kind of see that pattern. 2 over n minus 1 over n is like 1 over n. That's the big N, right? Plus, let's see, 2n plus 1 minus, well, it's going to just be 1 over big N plus 1. All right? This is the nth partial sum. Let me keep writing this down. And I see 2 minus 1/2 plus 2 n plus 2 plus a sum. And let's write down this general term over here. And just to make the counting easier for me, I'm going to say j equals 3 to n plus 1. And this is going to be 1. What goes on bottom? J. All right, before you do anything, I want to make sure that works. You get 3, 4, go up to n plus 1. All right, what I'm going to do is multiply by 2 now, and I'll write this down for you. Sn is equal to minus 1 plus 4 n plus 2 plus 2, the sum j equals 3 to n plus 1, 1 over j. Well, you know what you're trying to do? Look at this thing here and make some determination about it. And before you go on, I want to make sure you, in the key, we've reached the milestone that they suggest we reach at, right? And we got that. Now what I'm going to do is look at, what happens when n goes towards infinity. Well, I want to point out to you that, kind of looking at it, this will always be minus 1. That's not a problem. When n goes to infinity, in this particular term over here, this goes to 0. Right? When n gets really large, that goes to 0 quickly. But this guy over here should be recognizable as a divergent harmonic series. So what do we know about the original series? It diverges. This series here, where is it? Oh, it's on the notes, by the way. So the series that we were given diverges. Let me write that down for you. The series here, j equals 1 to infinity, 2j, j plus 1, j plus 2 is divergent. And it's over. Again, look at the key. I want to make sure it does say that in the key for you. I'm looking at it now. Yeah, and Divergent harmonic series include our infinite series diverges. All right, we're done. Thank you.